In this video, we're going to be talking about measuring. So we're going to talk about the different units of measurement. So what are our base units in the metric system? We're going to talk about the different prefixes that modify that base unit. So that's how we get things like centi or milli or kilo. We'll talk about what they mean, how they modify it, and what that means for scientific notation, because we're going to use those when it comes time to actually perform conversions. We're going to talk about how to properly take a measurement and what uncertainty is in a measurement, and how to read the measurement of volume of different liquids in a graduated cylinder. You will need something to write with, you'll need something to write on. You will not need a calculator for this because we're not going to do any math. And once you have those couple of things, let's get started. What we work with most often in this class is going to be a measurement. So most of the numbers are going to be based on measurements. And every measurement will have at least two parts. Two parts for right now. We'll add in a third part later on once it's appropriate. What you need is you need a quantity, which is the number. It tells you how many. And then you need some type of unit that sets the scale for how many of that thing. Right? So if I measured something and it came out to 5.1 grams, 5.1 is my quantity, and grams is my unit, which gives me the scale of what I'm measuring. So it's saying that I'm measuring mass, and then I have 5.1 of those units. For the metric system or the SI system, there are 7 base units, and they are on the screen here. So mass is going to be the kilogram, not quite the gram, it's actually the kilogram. Length is a meter, time is a second, so far nothing that earth-shattering. The amount of a substance is going to be measured in something called a mole. We're going to use moles almost exclusively this year. Temperature. Temperature in the metric system or the SI system is not measured in degrees Celsius. It's measured in Kelvin. The reason why this is important is because the Kelvin temperature scale, all the numbers are positive, whereas the Celsius scale, you can go negative. The conversion between Kelvin and Celsius is very straightforward. The Kelvin temperature equals the Celsius temperature plus 273. Know that conversion. And for volume, the measurement for volume, if it's a solid, is the cubic centimeter, because remember, volume is length times width times height. Or for a liquid or a gas, it will be the liter. One thing to keep in mind, and this is a common conversion, so again, have this written down, know this. 1 cubic centimeter is equal to 1 milliliter. That's a very common conversion, something you're going to use a lot, so make sure that you know that one. So those are our 7 base units, and then what we do with those base units is we modify that scale by using a series of prefixes. You guys are familiar with this because you've been using them growing up. You remember King Hector drinks unusually dark chocolate milk. That gives you all the way from 1,000 down to 1 over 1,000. We're going to expand it a little bit more. We're going to go from 1 billion all the way down to 1 billionth. So our prefix here, 1 billion, 1 billion scientific notation is 10 to the 9th, gets the prefix giga, which is capital G. Mega is a million. Kilo is still 1,000. We really don't use hecta or deca at all in measurements, so we generally tend to skip those. Then we have the base unit in the middle, followed by deci, which is 1/10th, centi, which is 100th, milli, which is 1,000th, micro, which is a millionth. Now you notice the symbol from micro is that weirdly shaped U. That is the Greek letter mu, which is what we use for micro. And then nano, which is 1 billionth, which gets the prefix lowercase n. Right, so have those written down because we are going to be using them when it comes time to do conversions. But let's start talking a little bit about how to take measurements and some uncertainty in measurements. Because whenever you take any measurement, it's always going to have some amount of uncertainty, some amount of estimation in it, even if you're using a digital device. If you put something on a digital scale, the last digit in that scale is rounded, because it can't actually calculate out past what the readout says. So what we have to do is we have to establish a standard practice when it comes to measuring. This standard practice is we read the digits that are on the device, and then we estimate one more decimal place past that. We have a ruler here. You see that this ruler is measured in centimeters. 1 centimeter up through, at the edge, 10 centimeters. Since it's measured in centimeter, we're going to break that up so one more decimal place is the 1/10 of a centimeter or the millimeter line. When we measure this pencil, we're going to measure to the nearest 1/10 of a centimeter. So we look at where the tip is. The tip is between 7 and an 8, and we're going to decide where between 7 and 8 it is. It looks like it's about halfway, so we'll say 7.5. If you said 7.4 or 7.6, that's okay. Just the act of getting that last digit of estimation makes your answer much more precise, and it gives you better calculations when you go to do the math later on. Right, so this is 7.5 centimeter. Quantity, unit. Always keep that in mind. One other thing to keep in mind when you're measuring in the lab is that you want everything to be at eye level. So that means that if you're measuring a pencil like this against a ruler, you don't want to be really far to the right or really far to the left. If you're measuring something vertically, you don't want to be really above it or very below it, because you get what's called parallax error, which is based on the angle that you're measuring at. So we want to avoid it by going directly at eye level in every possible direction with it. Which brings us to measuring the volume of a liquid. You guys are probably already familiar with this. To measure the volume of a liquid, all liquids in a glass container will have this little curve on it. That curve is called a meniscus. We measure the volume at the bottom of the meniscus. So for our example here, the level of the water is somewhere between 19 and 20 milliliters. We're going to measure one more decimal place past that based on where we think it is. Now, I think the bottom of that curve comes a little bit closer to the 19 than it does to the 20. So I'm going to say 19.4 milliliters. If you think it's right in the middle, you can say 19.5. That's perfectly fine. Again, the act of this estimation is what gives you the better result. Alright, so that is measuring. We're going to do some measuring practice in class. We're also going to talk a little bit about what the different pieces of glassware are actually used for, so whether they're there to contain a liquid or to deliver a liquid into a reaction. Our next video, we're going to go over dimensional analysis, which is conversions. So we're going to have fun multiplying over and over again by the number 1.